Good morning to you all. I am Mr. Ish. Thank you for joining me. We're looking here at specific type of questions that appear on exams, standardized exams, properties which result from similar triangles. We have a depiction over here that is indeed composed of similar triangles. If you look here at this small triangle, it looks something like this. If you look at the larger triangle, you know it looks like this. The way I've drawn these angles, this angle right here would be equal to that angle right over here. So everything with regards to these is similar. You can deduce this is equal to that because we have here pair of parallel lines. This segment and this segment are parallel, therefore the property of these similar triangles will arise as a result of that. Remember, when you have questions related to similar triangles, much of your computation will be based on ratios and or proportions. You have to find the length of this base of your small triangle given the base of your large triangle a certain height and another certain height. And the best way to proceed with this, using the fact that we have a similar triangles presented here, is use ratios. We have a base x divided by its corresponding height of that triangle right here, that would be 4, is equal to the base of the large triangle, which would be 5, divided by its corresponding height, which would be all of that up to 10. And you would simply just solve for x. You wouldn't even have to bring trigonometry in here. You'd have a 10x is equal to 20, and then x is equal to 2, and that right there would be your answer. And it would indeed make sense. This value here is 2. Think about the relationship between a 4 and a 10. If you did 10, you divide by 4, you have a 2.5. If you take this 2.5 and you multiply it with the value you've obtained for x, 2.5 times 2, you get a 5. So everything works out with this specific property of similar triangles. Everything here falling very well into ratios and or proportions. Let's look at one more question. In this particular example, we have similar triangles drawn, but they end up being right triangles. We have a large base over here 10, we have a height here 6, we have a height here 3, we have to find that specific base. How do we have similar triangles here? We have a small triangle right here which has x and a 3. Then we also have a large right triangle, and these are both right triangles as you see. This large one has a base of 10, it has a height of 6. You can do exactly as you're seeing the properties of similar triangles in terms of a ratio. You don't even have to bring angles, but this angle right over here and this angle are shared. This angle is shared with that and is shared with the large. Everything here is indeed similar. This height and this height are parallel. You got 90 degrees. Exactly as you're seeing is exactly how you will determine your ratio. You'll have an x over 10. The small base divided by the large base is equal to 3 over 6, the small triangle's height and the large triangle's height, and you do everything from there. 6x is equal to 30, x is equal to 30 divided by 6, which is 5. And now when you plug this 5 right over here, you'll see everything will make sense. For the small triangle, when you compare the base with the large, it's a factor of a 2. When you compare the height of the small with the large, it's again a factor of a 2. And you're seeing that times 2 and times 2, and everything has been completed. So remember, when you're looking at properties of similar triangles, once you've determined that you indeed have similar triangles, you can use a ratio, and that's perhaps the best way to solve these. And your ratio formula is nothing more than A over B is equal to C over D. Thank you. Have a great day. Bye.